Free space. Free space is the idea of you take an image and you want to map it to where where can you drive, where is the roadway. And what I'm showing here, the roadway is colored by green. And let me show you, this is quite interesting. So, for example, here you see that the algorithm, which is a deep network algorithm, understood that this part, the curb, and what's above the curb is not part of the road. But let's go a bit further, and I'll stop it in a place which is really impressive. Here, when you look at this, the texture of the sidewalk here, of the pavement, is exactly identical to the texture of the road. So how did the system know that this is not road and this is road? It knows that because it learned the context. There's a lot of context processing going on here, so it's not a local, take an area of an image and decide whether it's a roadway or not a roadway. It's a full image, and this is one of the powers of deep networks, that you can leverage context into it. And here again, the challenge is how to model the output. Is the output a label per pixel? If you do that, maybe you'll have a nice demo to show, but it will not work in practice. It will not work at the accuracy that our feature works on. We launched this on Tesla Autopilot a few months ago, and it's an integral part of any boundary function feature from 2016 and forward. So this is a function that is running 36 frames per second, high resolution, and does things like what you see here. We have extensions of it where at the boundary of the free space there is a label, whether it's we have 15 different categories, whether it's a vehicle, whether it's the side of a vehicle, whether it's a curb, a barrier, a guardrail, and so forth and so forth. So this is trying to give you the environmental model. And here you see this from multiple cameras. So from multiple cameras we know where the free space is, the boundaries of the free space. On the boundary of this free space we have a category label. What is it? Is it a curb? What kind of path delimiter is it? Is it a path delimiter of a moving object, path delimiter of a stationary object? What kind of stationary object it is? Another example of deep network is path planning using holistic cues. So in order to support hands-free driving without a map, just by sensing, you need to know where the path is. Now, in situations where you don't see the lanes, like what you see here, there are no visible lane marks. Yet humans can drive quite easily in this case. And what you see here, that the system has learned and predicts the path correctly, even when there are no lane marks. Again, the question is how to model the output. It's kind of a very tricky modeling. How to use multi-frame in this case, what kind of a recurrent neural network you need to build here. All of these things are not kind of a run-of-the-mill garden variety problems that people handle. This was first launched on the Tesla Autopilot, and it's an integral part of our lane detection going forward. So let me show you, not in a PowerPoint. This is I downloaded this from the web. This is someone driving hands-free on the Tesla Autopilot.
Now my feet are off the accelerator.
Okay, and what I want to show you here, so you see that she's driving hands-free, and the point I want to make here, do you see the lanes? Nothing. There are no lanes. There are shadows, there's low light, there are hardly any lanes. There's a lead vehicle. The system fuses information from lead vehicle, but if there's no lane information, the system deactivates. It will not do hands-free driving just because there's a lead vehicle. And this is the power of this HPP, this holistic path planning feature. And you see this is already in serious production, tens of thousands of vehicles already.